Hello and welcome. Today we will be discussing how to solve systems of linear equations using graphing. Now this is the third and final method that we will be using to solve systems of linear equations. We've done substitution and we've done substitution and we've done elimination. Now we'll be moving on into graphing. With graphing, it's exactly as it sounds. We will be graphing these equations to see where they intersect. That point of intersection, if they do intersect, is the solution to the pairs or to the system, right? This is our system here. So we are looking for a solution for both x and y that satisfies this system. Now there won't always be a solution for x and y. Sometimes we may have infinite number of solutions, being if we have the same equation occurring twice, or we may have no solution if the lines are parallel, for example. But in most cases we may have at least one solution. So let's go ahead and check this one and find out if we have a solution for us. So what we need to do is we need to graph our lines. If you notice, these are both linear equations. The first one here is already in what's known as slope-intercept form. If you're not familiar with slope-intercept form, that is y equals mx plus b. But hopefully you are, because that is how we are going to use this equation to graph it, right? If it's in slope-intercept form, we can easily translate this to our graph. Being this is already in slope-intercept form and knowing that this is my slope right here, attached to my x value, I have a slope of -1. I also know my y-intercept is a +2, right? Whatever is in the b value is my y-intercept. Remember, y equals mx plus b. Remember, m is your slope, b is your y-intercept. Start with the y-intercept, +2. That means we go to 2 on our y-intercept. This is our y, this is our x. You need to distinguish the difference between the two, always, always. So start at that +2, and from there we will use our slope. It is -x, which is -1. Remember, every variable always has a 1 in front of it, and we always want to write our slope as y over x. And in this case, if we have a value of 1, as a fraction, 1 would be 1 over 1. So that means I have a slope of 1 over 1 here. So I'm going down 1, since it's negative, and over 1. And I can continue to do this as many times as I like. Down 1, over 1, down 1, over 1. Right, so I can continue to draw this, graph these points, and then I can draw my line through these points, right? So I've gone ahead and graphed my first line. Now what we need to do is graph our second line. If you'll notice here though, our second equation is not in slope-intercept form. It is not in the form of y equals mx plus b. So we need to get it into that form so we can graph it. So what we need to do is rewrite the equation -12x plus 4y equals -8. And we need to write it in slope-intercept form. So if you notice, that means y is on the left side of the equal sign and everything else, our x value and our y-intercept, are on the right side. So I need to start by moving my x value, get that away from my y value and move that over to the other side. What we do to one side, we do to the other, and we're using our inverse operation of negative, which is +12x. Move that over here, and that's going to be 4y equals 12x minus 8. Now I'm not quite finished. I need to isolate y, because remember the equation is y equals mx plus b. It's okay to have a value attached to x, and it's okay to have an isolated whole number here like this, a constant that doesn't have any variables, but we need to get rid of this number that's attached to the y. So I'm going to use the inverse property of multiplication and divide, right? Divide everything by 4. That's going to remove the 4 here, and I'll have my equation of y equals 3x minus 2. And now, since I'm in slope-intercept form, I can graph starting with my b value, my y-intercept. Start at our point of -2 now. So starting from -2, I'm using my slope of 3, but recall slope is in the form of y over x, so it is a fraction. So it is 3, and 3 as a fraction is 3 over 1. So from -2, I'm using my slope of 3 over 1, up 3, 1, 2, 3, and then over 1 time. And I'll see I actually have an intersection point perfectly right there. And I'll see these two lines intersect at the point of 1, 1, which will be my solution to both to both linear equations. And that is how we solve systems of linear equations using graphing.